Energy part 3, the renewable energies. Remember that the word renewable means that it can either regrow or regenerate within our lifetimes. Technically, things like fossil fuels are kind of renewable, but they take millions of years to form, so by the time we get more, we'll be dead. Renewable things include biomass, water power or hydropower, geothermal, wind, and solar. We're going to see each one, what it is, pros and cons of each one coming up. But a quick history of renewable energies. Until we discovered fossil fuels, which was like the 1800s, it was usually wood. Trees, you can burn trees. There you go. After oil and gas were discovered and we realized that, we can burn these things and they make a lot more energy than trees, the fossil fuels became the main energy source up until quite recently, like the last 50 years or so, when we realized that maybe we can find other ways. As of 2020, about 12% of the USA's energy is from something renewable. Nuclear, depending on where you look, it might count as renewable, it might count as non-renewable, so that's why I kind of put it by itself, but we're just looking at all the other stuff now. And so 2020, you can see most of our energy is not renewable. A very small amount is nuclear, but the greatest amount is fossil fuels. Here is U.S. energy consumption by major sources in selected years. So for a very long time, it was just trees in that purple. And then it was just coal and trees. And the red is oil and coal and trees. And then blue is natural gas. The light blue and the green are the more renewable ones. You can see we're getting more of it, but it's still primarily the other ones. That little tiny brown line is nuclear. Starting with biomass. We burn something for energy. In the end, the thing is burned, it turns a turbine, which generates electricity. So in the end, it's all the same. It's what are we doing to get to that end point. Most often used plants for biomass is obviously wood from trees, but we can also use corn and soy. We can even take those biomass sources and ferment them into a liquid like ethanol. They have some cars that are powered by ethanol now. It's still coming from the same source. We just turned it into a liquid so we can use it. Pros of biomass. It's renewable. So you can regrow trees or corn or whatever, like that. It reduces waste because things like corn and soy, there's only certain parts of it that we can eat. So we can take some of those other parts and use them to burn. Now, with corn, we have to actually physically use the corn to make ethanol. That's kind of its whole own other thing. But even things like trees, we can't use the whole tree to make wood to build things, so we can burn parts that we can't use. It is reliable. We know it's going to make energy in a certain amount. If you are planting the plants at the same rate that you're cutting them down and burning them, then it's called carbon neutral, because the carbon you're putting into the atmosphere is taken out by the plants that you are planting. It costs a lot, though, to use biomass, and to convert biomass into things like ethanol, it takes up a lot of space. If you're cutting down a bunch of trees, you're taking all that space. There is some deforestation. There is some air pollution. You have to have machines that cut down the things. If you burn fuels like wood, then that's going to release some carbon into the air. So, not the best, but probably the easiest of all these. Literally just go cut down a tree and burn it. Hydroelectric comes from water flowing. So usually what we would do is we build a dam, we put a bunch of water behind it, and that water is going to naturally want to flow downhill because that's what water does. Instead of just letting it all rush out, we have a certain tube that it can go down. As the water's flowing down, we use it to turn turbines, generate electricity. We're kind of using what water would do anyway to make electricity. It is renewable. As long as you have water back there, it's going to keep going. You can turn it on or off. Like if you see one of those big, huge dams like the Hoover Dam, there's a bunch of generators in there. So you can have them all running 100% if you need a lot of energy, or you can only have a couple that are running. So you can change it depending on how much energy we need. It can make a crap ton of energy. If you got a lot of water, it can make a lot. And also, back here behind, it makes a reservoir, which can then be used for recreational things, like you can put fish in there and have a fishing area or a boating area. People can frolic around in the water. Oop, wrong way. Cons. That dam messes up the environment. You gotta put a whole bunch of concrete in there. That's gonna mess up the environment. It displaces people and animals. They gotta move out of their home, because now we gotta make this big lake reservoir to put behind the dam. So we're gonna have to flood an area. It's going to have to get rid of a whole ecosystem. If people live there, too bad, they better move or they're going to get flooded. It is very expensive to put that much concrete in one place. And you can only build it in a place where there's kind of already water. Like, we can't force a reservoir to exist. You kind of have to move the water to that area to be able to use it on these. So places where you usually see dams built are places where there was already a big river. Like, there's one in Egypt on the Nile River. There's one, the Hoover Dam takes advantage of the big rivers out in the western United States. So we can't really put it everywhere. You have to put it where there's already water. Geothermal. Geo is earth. So down below the ground, there is lava, right? It's hot down there. So if you have water near the hot, it's going to create steam that we can then use to make energy. So basically, we find areas where there is hot water underground. We pump it up, it turns the turbines, makes the generator, make electricity, and then we send the cool stuff back down. Renewable, obviously, as long as the earth is hot, it's going to stay there. It doesn't damage the land as much as some other energy sources. You just have to sort of drill a hole down in, 2 holes, one for coming up, one for going down. There's no pollution at all. This doesn't release anything besides maybe some steam from all the water coming out. And it's reliable. As long as the earth exists, it's going to be fine. But it has to be kind of close to the surface. We can't do it everywhere. You have to dig down into the earth to get these things in there. And if it's too deep, then it's not worth it. So it kind of has to be close to the surface. It's expensive to dig that and build all those places. And plus, when we start pumping that water around, the rock, this brown stuff that's on top, might become unstable, and that could cause sinkholes and other things like that. Sort of the same problems we have with mining and coal drilling and oil drilling. I mean, when we go down deep under the surface, it could cause instability on top. Wind. We've been using wind power since forever. If you see like those old-fashioned windmills, you see them a lot in Europe, kind of like the northeast area, if you look at the historical places. That's still wind power. This is more modern wind power that we're talking about. So we have the blades that get pushed by the wind. Inside of this body part back behind, there's a generator. As those blades spin, it charges the generator, which then has a cable that goes down this long part and sends it out into the power grid. It's now electricity. In the ye olden days, these turbines used to spin and then they would move like gears inside of the windmill building to do things. Here we are doing kind of the same thing, but tinier, and making it into electricity. We can put these turbines on land in places where it's very windy. And we can also put them out in the ocean. If you've ever driven on the Pennsylvania Turnpike over by Somerset, there's a whole bunch of these. You can see them. Pros, obviously, wind's not going anywhere. As long as the earth is still moving, we're still going to have wind. We don't have to do anything. It's just there. It doesn't cost very much compared to some other things. It does not take up that much space. And there's zero pollution. None. Once you get that wind turbine up there, it's done. There's no pollution. It does have some environmental impact, especially because we have to mine the materials to build the wind turbine. Why do I cannot say words today? We have to mine materials to build the windmill. There we go. Words. We have to have a certain area where we put all these windmills, so that's going to disrupt that environment. And in some places, it messes with birds. because it's now up in the sky and the birds aren't used to having that there. Eventually the birds adapt, but when they first go up, it can impact the birds. It does depend on wind patterns, so you got to put them in just the right place to get the right amount of wind. And they're not quiet. From far away, they don't make any noise, but if you live very close to them, those turbines are making a noise, so it's not great. And some people will say that it's like visual, quote unquote, pollution, where like, oh, I can see them. Really? To those people, I say, well, would you rather see smokestacks? It's a windmill. It's not that big of a deal. Anyway, solar energy. We have these solar panels, which are called photovoltaic cells, if you want to get fancy. And they use a reaction to transform sunlight into energy. You can put them anywhere, on almost anything. Renewable, again. Over time, it doesn't cost that much money to maintain. You just have to maintain the individual panels. When they're pretty hardy, they can stand up to things. You can make a lot of energy and then save it in a generator. And it works everywhere, because everywhere on Earth has the sun. So as long as you see the sun, it will work. Cons are, they are expensive to build. So if you wanted to put solar panels on your house, it's expensive up front. You have to pay a lot for the solar panel themselves because they're expensive to make, and you have to pay to get them installed the right way. It doesn't work as well when it's cloudy or at night. But again, you can attach them to a generator. So all day, the solar panels on your house can be making energy the whole day as long as there's sun. And then at night, you can pull from that generator. Some people who use solar energy in their homes actually make enough energy that they can send some back to the power company. So the power company's paying them. It does take up space, especially these big solar farms. They take up huge amounts of space. And they require metals to be mined in order to build these solar panels. One neat thing I saw, I don't know how common it is, but I did see one where they had a parking lot with all the solar panels kind of up higher and the people parked underneath them, which I thought was a really neat idea. They should do that more often. That way your cars stay cool, but you're also generating solar power. You should do that more often. What's the future? Within the next 20-ish years or so, we're projected that it'll be probably about even with coal and gas. There are some countries that already are there. They're already more equal to fuels like coal and gas or above it. Solar and geothermal work well for homes and businesses. Wind turbines work best for whole communities. You could put a wind turbine in your backyard, but that's kind of big. Things like biodiesel, bioethanol, solar power, electric power can work on cars and other vehicles. So we're getting there. It's definitely getting better. Some pitches to end with. As of 2012, because some of this data takes a while to compile from all the countries. Here are where we have the most renewable electricity in different areas. You can see hydropower. United States is in all of these, pretty much. We're using all of them. But there are some countries that can't use all of them. So we have some places that it just won't work. Solar power is one that's pretty much everywhere. We're getting there. Renewable energy share of global energy production. This is breaking it down by percentages, where the other one we just had picture. This is as of 2018. It's getting better. The main issue with a lot of these fuels is that our machines and cars and other vehicles run on liquid fuel. When you try to convert them into electric or like solar panels, that's a whole different kind of engine. And you end up having like those batteries that have issues and some cars explode and things like that. The easiest way to convert our current system with gas into a new system that's not as bad for the environment is to use liquid fuels like your bioethanol, your biofuels, which is great. But it's still not the best because it still reduces pollution. We have issues with like cutting down the trees and all that. It's going to take a while for us to get to a point where we are not using those fuels. especially in other countries that are not the United States. You can see on this map we had all those gray countries. Some of them we just don't have data on. Some of them chose to go a different direction with things. And some of them, it's going to be really hard to get them to be that way. Like most of Africa, the Middle East, Asia, South America, some of those countries are still struggling a lot. And they're still on coal or oil because that's what they need. It's going to take a while for everybody to switch over. Not everybody has the same advantages that we do in countries like the United States. And nuclear, if you notice, all this time, nuclear's kind of been pretty low. It's because people are afraid of nuclear. They don't understand the benefits of it. They just see stuff like Chernobyl and they're like, holy crap, we're all going to die. So they don't want to have nuclear nearby them. But there are still some places where nuclear is coming up. Maybe in the future we'll have a good balance of nuclear and the other renewables. But we'll hope. We can hope for the future. Cross our fingers. So with all these different energy sources, the fossil fuels, the nuclear, the renewables, you should know kind of like pros and cons of them. What are they? What are the benefits of them? What are the drawbacks to them? Which ones are better for the environment? Which ones are worse for the environment? Things like that. That's kind of what we're focusing on here. We will be wrapping up before break with some stuff about renewable energy, and then we're going to have our test before Easter break. So stay tuned for that. But those are all the notes before your test. We'll see you in the next unit.